So we have done Harrod Domar equation in the last class. Now let us try to bring population growth in the Harrod Domar equation, right? So if you remember, we have done this guy. So we have theta yt plus 1 is equal to 1 minus delta theta capital YT. This is the expression which we have derived in the last class, right? So you might look at that recording. So this is this is what your capital YT plus 1, that is your output GDP next period, capital YT GDP this period. So if I want to write everything in terms of per capita output, so small yt is the per capita output or per capita GDP is capital YT upon PT. So real GDP upon population. Is small yt into PT. Capital YT plus 1 is small yt plus 1 into PT plus 1, right? So wherever we have capital YT plus 1, let us write this expression, right? So output your GDP this period, GDP next period, written in terms of per capita output and population. So we have theta. In place of capital YT plus 1, we will write small yt plus 1 into capital PT plus 1 equals to 1 minus delta theta. Capital YT is small yt into small pt plus s. Capital YT is small yt into small pt. So you divide throughout by pt. Divide throughout by pt. So you have what? Theta yt plus 1 pt plus 1 pt equals to 1 minus delta theta small yt and small pt pt plus s small yt pt upon pt. Fair enough. We'll do one more division, right? So you have divide out by theta small yt. So you have theta small yt plus 1 into capital PT plus 1 upon theta small yt into PT equals to 1 minus delta theta small yt whole upon theta small yt pt plus s small yt upon theta. Why am I writing pt here? Okay. Should not be no pt here. Theta small yt, right? Okay. And we are left out with this expression. We are left out with this expression. small yt plus 1 upon small yt, pt plus 1 upon small pt equals to 1 minus delta plus s upon theta. Now, if you remember, you know this, that the population next period is going to be population this period plus growth rate of population into population this period. So basically it means 1 plus n pt. Similarly, output next period is going to be output this period plus growth rate in real GDP into output next period, output this period. So this is 1 plus G capital YT. And similarly, you guys can write output per capita next period is output per capita this period plus growth rate in per capita output small g star into output per capita this period. So basically this is 1 plus small g star into small yt. So from here, I can write small yt plus 1 upon small yt as what? 1 plus g star. You can see this, right? Small yt plus 1 upon small yt is 1 plus g star. pt plus 1 upon pt is 1 plus n, right? Equals to 1 minus delta plus s upon theta. So basically now we can write s upon theta equals to 1 plus g star into 1 plus n minus 1 upon minus 1 minus delta. So this expression is taking care of the population growth also, right? Population growth also. You with me? Okay. Now let's do a very simple numerical. This is an example. Not example related to population growth, but this is a simple example on Harrod Domar model. Please write. Suppose during last decade, real GDP in country grew by 5.8%. Right. While investment averaged 23.1% of GDP. What was the country's incremental capital output ratio during last decade? During the last decade. Well, you know this that Harrod Domar model assumes that investment rate is equal to the savings rate, that is savings investment equilibrium. So if the investment rate is 23.1%, that is the savings rate is also 23.1%. Harrod Domar model assumes investment rate is equal to savings rate is equal to 23.1%. And according to Harrod Domar model, this is the uh, growth rate. Savings rate upon incremental capital output ratio minus depreciation rate. Here, nothing is being told about depreciation rate, so we'll assume it to be zero. So what is your incremental capital output ratio? S upon G. S upon G. You are given with a savings rate of 23.1%, so you can write this as 0.231. And you are given with a growth rate of 5.8%, so you can write as 0.058. And that thing will come out to be 3.98. So ICOR is 3.98, right? Okay, so this is what I wanted to do in this class. I'll take the discussion further in the next one. Thank you, Beta.